Today I'm tuning and assembling a Comprod VHF antenna. From some distance it might appear as a UHF antenna, but you see the matching element on the top makes the whole antenna shorter. We have another one made by Sinclair, way longer. It's another 3 feet longer than this one. But this one it's a unity gain, and the performance might not be as great as the other one. We use it for a small site, maybe 500-meter radius site, but we choose this one because of durability near the water, near the river, where the ocean moves in with some salt water and vapors, a corrosive environment. So we went with this one instead of some cheaper version. And this one comes with some sort of a mounting hardware and a female connector. So right here I have a simple setup, and it took me a bit to install it, maybe a couple of minutes. But also I have to adjust the ground rods. So these two perpendicular aluminum rods have to be adjusted at certain height according to your customer frequency. So in my case I have a repeater frequency, and usually I go with receive side. I favor receive side of the repeater because the repeater can deliver lots of power, in this case 25 watts, but the receive side need to be able to hear the portables, which are limited to 5 watts when the battery is fresh. So some portables might have only 2 watts out. So what I did, I tried to tune this one for the higher frequency. I may get a little bit of higher reflected that way, but let's check out frequencies here. So I have about 167 megahertz, and VSWR in this case is 105. So let's remove some of the reflection. So I'm trying to tune it in 167, and as you see here, at 170 I have 1.2, and 167 105. I got, at some point I got 103 at a lower frequency, 164 or something like that. So this is pretty good antenna. So let me set few more markers. So I set few markers here around the best VSWR, and if I look at the marker table, is at 164 megahertz I have 1.2. Then I have 109, 108, 105 at 167, like I said, my kind of desired frequency. Then 114, 123. So it's pretty good within like 6 megahertz. Very good. And I don't mind to set it for the receive side of the repeater instead of trying to minimize the reflected power, because it's going to be minimal anyway. So that's the way it shows here on my company spectrum analyzer. It's an Anritsu, and that's the antenna. So again, you tune that antenna by moving those ground rods up and down. If you move it down, if you adjust those ground rods farther from the active element, that means you will lower the tuning frequency. So the longer tuning element or longer rod, even the dipoles or the tuning fork, you could say, in sound circuit, sound systems, audio system, tuning fork is longer, the vibrating frequency is lower. Same thing with this antenna. So undo those clamps, right, and move it a bit lower, then you will get a lower frequency. If you go shorter element, tuning element, means the ground rods go higher, closer to that adapting or matching element, then the frequency, the tuning frequency of the antenna is higher. So that's kind of a quick setup, and I'm going to install this antenna probably by next week, and I may have to use a lift, all that. So a quick antenna testing and setup. Bye bye.